Good morning from Dhaka, Bangladesh. This is the fifth lecture of AS and A-level chemistry lecture series. In the fourth lecture, I just started with the periodic table and electronic structure, and then the properties of elements in periodic table. We talked about modern periodic law, chemical and physical properties of elements vary periodically with increasing atomic numbers. So there are physical properties as well as chemical properties. Let's talk about some of the physical properties, how it vary with the period and also with group. The melting point. This figure shows the melting point, variation of melting point. The melting point depends on the structure and bonding between the elements. Well, we can see that melting point sharply rise along a period, and this is how it rise. A group, I said group 1 to group 2, and then group up to group 13, because these are metals. And if we go to group 14, we can see that carbon and silicon, which form giant covalent structure, and that have got high strong structure and highly directional one. This means the melting point of this group 4 elements are very high. But if we go to group 15 to 18 elements, these are non-metals, and the structure of these non-metals bonds with weak molecular force, and hence the low melting point. We can see that how it goes here. This is the group 4, 15, and 18, and then it again rises, and there are some break in the figure, and this is due to the electronic structure, which we will see during our lectures and series of the lectures. Well, I talked about ionization energy and showed what is ionization energy, etc. And this ionization energy depends on 3 atomic parameters. These are size and positive nuclear charge, distance between outermost electron and the nucleus, the shielding effect of electrons. Well, if we go quickly, we can see that it rises, and then again it falls back in period 1, and then in period 2 it rises and rises with some break here and there. And I say this break is due to the electronic configuration. I can show one of this example here. You see, beryllium has got an electronic structure 1s2, 2s2. However, boron has got an electronic structure 1s2, 2s2, 2p1. We know it. So here, boron is lower in ionization energy than that of beryllium. Why? Because 2s2 electrons are filled orbitals, filled subshell orbitals. It is difficult to remove electron from here than that of boron, where it is 1 electron in 2p orbitals. This is why there is a break here, and similar break will get for nitrogen, oxygen here. But then we talk about the group. You see, the group trend is lowering if we go down the group. Yes, lithium, then sodium, then potassium. Similarly, helium, neon, argon, etc. And we can see another group, beryllium, magnesium, calcium. In the group, it lowers down the group. And in the period, it goes from left to right. It raises from left to right with few breaks here and there. Well, we discussed in length what is periodic table. We talked about period and group. The horizontal one is the period, and the vertical one is the group. So when I say that this one here from here, it is a period, but this one, it's a group. If we go to this is a group, this 1, to this one, 11, 19, this belongs to a group. And therefore, we know what is period and what is group. And I would request anyone to, when I talk about period and group, you refer to the periodic table and get what is called period and group. Now we go back to a physical properties, which is electronegativity of atoms. What it is the tendency of an atom to attract bonding pair of electron towards itself. And that has a scale, which is called Pauling scale. The electronegativity, the highest one is fluorine, which is almost up to 4. And then rest are below 4. The K scale is 4 and rest all elements are below 4. So here we can see that electronegativity, according to Pauling scale, increases along a period and decreases along a group. So I talked about what is electronegativity and how it varies along the in the periodic table. That's what we also mentioned in these slides. Now we are talking about electron affinity. Many people do confuse between electron affinity and electronegativity. I say electronegativity is a power of attraction of bonding pair of electron towards an atom nucleus. But electron affinity, it is just opposite to ionization energy. What we call the ionization energy? Ionization energy is a gaseous atom. If we knock out an electron from a gaseous atom and it becomes positively charged ion, the energy required for this one is called first ionization energy. Here we are talking about electron affinity, the opposite of it. When a neutral gaseous atom takes up an electron and it becomes a singly charged negative ion, the energy required for this is called electron affinity. For example, here, chlorine, a neutral atom, a gaseous chlorine, which takes up an electron and then becomes chloride ion, gaseous ion, and this is called, the energy required for it is called electron affinity. And we can see electron affinity given in electron volt and versus atomic number. We see again there is a general trend to increase along a period and decrease along a group. Density of the all we know about elements, compounds, etc. That has got density, and which is the mass of a unit volume of element or compound or so. And this is expressed in gram per cubic centimeter. So we can also see variation, periodic variation of density in the periodic table. So we are plotting density against atomic number, and you can see it varies periodically and so forth periodically. It varies. But this is what we call the periodic variation of properties of elements, specifically physical properties of elements I showed in few slides. Next one is, this is an old version of periodic table. Here we have a period, we have group also, but this is not a IUPAC adapted periodic table. Many books in A-level and also A-level are using this periodic table. So that I mentioned here. You will see that the modern one has also a group and period, but then the period numbers are different. And but if we remember, we talked about S block elements, P block elements, F block elements, D block elements. This is what I have shown also. But this is no longer an IUPAC recommended version of periodic table, but some A-level textbook are showing this also. This is a periodic table where we showed every details about the elements, which one are solids, which one is liquid, which gas, and which are unknown yet whether it is solid or liquid. So we have 118 elements, and if you go to this periodic table, you can also mention the number of metals, number of metalloids, non-metals, noble gases, etc. by looking to this periodic table. There are many versions of periodic table, as I said, one can discuss, and if you go to website, and then you find different versions of periodic tables, I said before. So we finished the atomic structure and periodic table, but there are few terms which you can also include in this lecture, what we call empirical and molecular formula of compounds, stoichiometry of a reaction, limiting reagent in chemical reaction, significant figures in calculation. This we need to discuss before we go to next chapter, which is chemical bonding. I would like to emphasize here that when a student understands atomic structure and periodic table very carefully, or I would say understand clearly, he or she will have very easy going in other chapters of chemistry. And I also believe that he or she will find fun in reading chemistry, not afraid of chemistry. So please go carefully to understand atomic structure and periodic table so much so you can, and take it as a fun lectures and read, and then you will be getting careful and very beautiful knowledge of chemistry, basic knowledge of chemistry. Now we go for these few terms. Well, you see, chemists always represent reactants and products by chemical reactions or equation. I will here discuss what we call chemical reactions and what we call chemical equations. Example here. The first step, there is a problem. What mass of iron can be obtained from 1 kilogram of iron trioxide? There is a problem. And if you want to write the chemical reaction of it, here it is the chemical reaction of this, what I said in here, chemical reaction. You can see here, this is the left-hand product, left-hand chemical are called reactants, and the right-hand one are called products. You see the number of elements in this chemical equation, it is not balanced. When it is not balanced, we call it a chemical reaction. But when it is balanced, we call it a chemical equation. So what is balanced chemical equation? The left-hand side number of elements must be equal to right-hand side number of elements. So what we did here to make it balanced, we add 3 moles of carbon monoxide, and then we can see that we can make it balanced. So to write or to calculate anything, products or reaction, we need to know the chemical equation before we start calculating. So our problem was to find out how much iron we can get, that is mass of iron we can get from 1 kilogram of iron trioxide. You know, we have to then, in the step 2, find out the mass, find out mass of iron and molar ratio for iron trioxide and iron. And how do you get it? We can get the molar ratio from the equation, chemical equation, that is 1B. This is committed. What is it? We see here 1 mole of iron trioxide is in ratio 2 mole of iron. So what you got? We get molar mass of iron trioxide first, and that is 159.6 gram per mole. Why it is? Because we know that molar mass of iron is 55.8 gram, and here there are 2 iron, and then molar mass of oxygen 16.0 gram, and here we get 3 oxygen mole. Therefore, if we do calculate it, we get 159.6 gram per mole. Well, we get molar mass of iron, oxygen, and so all elements from the periodic table. In our case, iron is 55.8, you see here, and then oxygen we go here, 15.999, and we rounded it up as 60. So from this periodic table, we get the molar mass of what we call here, the molar mass as well as the molar mass of oxygen, etc. So if we calculate the molar mass of iron to 1 mole of iron 3 oxide, we get the mass is 159.6 gram per mole. Similarly, we get molar mass of iron, we get 111.6 gram per mole. And now we know 159.6 gram of iron 3 oxide gives us 111.6 gram of iron. And therefore 1 gram gives us this 0.70 gram of iron. And our question was 1 kilogram. So we convert it in 1 kilogram. That 1 kilogram of iron 3 oxide gives us 0.70 kilogram of iron. That's how we calculated the product or reactant from a chemical equation. Now I talk about empirical formula of a compound and molecular formula of a compound. What is the difference between these two? The empirical formula means simplest whole number ratio of elements in the molecule or formula. Molecular formula means the number of atoms of each element present in the formula. Well, we can talk about a little bit of ionic compound. The ionic compound is always its empirical formula. For example, this is magnesium oxide is an ionic compound, sodium chloride is an ionic compound. So it has its empirical formula like this. It does not give any molecular formula. Whereas empirical formula and molecular formula for simple inorganic molecules are often same. For example, water and ammonia. But when we go to organic molecules, we see there are different empirical and molecular formula for compounds. The empirical formula of butane is carbon 2, hydrogen 5, but its molecular formula is carbon 4, hydrogen 10. You see that here we had multiplying this unit by 4 and getting this formula, molecular formula. If we go for cyclohexane, whose empirical formula is CH2, and the molecular formula is C6H12. That is, this empirical formula is multiplied by 6. Now the question comes, how do we get empirical formula and molecular formula? I'm giving two problems here, and we will solve these problems and find out the empirical formula and molecular formula also. So the problem 1 is 20.1 gram of iron bromide sample showed that it contained 3.8 gram of iron and 16.3 gram of bromine. What is its empirical formula? So when we ask for an empirical formula, we have to give the molecular formula, relative molecular mass of iron, in this case iron and bromine, which you get from periodic table. We said that. Even sometimes we get analytical results in percentage. And from the percentage, we can also find out empirical formula. So I want to note it for you that abbreviation of M is the unit of molar mass in gram per mole. So the molar mass is given here, this one, the molar mass is given for iron and bromine in your question, and here copper, iron, and sulfur too. So if we take this information and go for calculating empirical formula, we can do it. In the next slide, we show the calculation. For problem 1, in question, the mass of iron is 3.8 gram, mass of bromine 16.3 gram. And molar mass of iron from periodic table, 55.8 gram per mole, and molar mass of bromine is 79.9 gram per mole. So mole of iron, we know amount of iron divided by molar mass. So we get mole of iron is 0.0681 mole. Similarly, we get mole of bromine and we get 0.204 mole. Now, if we take the ratio of iron and bromine, so this divided by this gives us 1, and bromine this divided by this, the simplest one gives us 3. So we get the empirical formula of iron bromide is Fe3Br, FeBr3. This is the empirical formula. If we remember in the last slide, in the question given, the analytical results of copper pyrites. It's an ore, copper ore. It's given copper is 34.6%, iron is 30.5%, sulfur is 39.4% by mass. That is what is the analytical result. We know the molar mass of copper, iron, and sulfur from periodic table. Now we know 100 gram of copper pyrites gives us the result is 34.6 gram of copper, 30.5 gram of iron, and 34.9 gram of sulfur. And if we take the mole of copper, iron, and sulfur, we get the result 0.545 mole of copper, 0.5446 mole of iron, and sulfur is 1.09 mole. So the simplest whole number of ratio of copper, iron, and sulfur is 1:1:2, and therefore the empirical formula of copper pyrites is this. So we now know how to find out the empirical. Well, you see, we have covered this much by our designated time. So we'll be taking the next slides in the next lecture. That means 6th lecture of the series. Thank you very much. We'll meet again in the next class or next lecture.